Hello and welcome back to our channel. This is the second part of the coding theory video. If you haven't watched the first part yet, where we discussed the ISBN code, click the link down below. In this second part of the video, we will cover the definition of a code, we will provide an example called repetition codes, and we will end our discussion with some general properties of code. Do you remember where we were last time? Yes. We are going back to the story to find out the error correction capacity of the ISBN code. As you might have noticed, Alice is really into codes. To expand her knowledge, she decides to go to the library, makes it to the mathematics section, and reaches to the book Algebraic Function Fields and Codes on the shelf. She brings it to her place and prepares a huge mug of chocolate. Now it is time to relax and read codes. The smell, that's her favorite. She takes a sip and something unpleasant happens. She cleans her desk and doesn't even realize that there is a small chocolate stain on the back of the book. But this means another error for Marta. She now needs to guess two digits. The first one can be a 3 or an 8. And the second one also can be a 3 or an 8. She decides to try all of the 4 possible combinations without knowing there is a surprise awaiting her. She starts with typing the version with 3's in both unknown positions. She now types the version with 3 in the first position and 8 in the second position. Now 8 in the first position and 3 in the second position. Lastly, 8 in both positions. But this is so confusing, says Marta, and wonders why. Because Marta, as you may remember, there is this book with 8's in both positions. Algebraic Function Fields and Codes. But there is also this other book. Geological Atlas of Africa, if you type 3's in both positions. Are you even more shocked? Let me start from the basic terms of coding theory. A code word is a finite sequence of symbols. Symbols? What do you mean by symbols? They can be anything you can think of, but usually we will consider alphabets or a set of numbers. I will now provide you some examples. For our first example, take your symbols to be the set of all integers between 0 and 9. Then the ISBN number of algebraic function fields and codes, which is 978, 35, 4076, 878, 4, is a code word of length 13. For the second example, we take the symbols to be the set of 0, 1. 0 is a code word of length 1, 0, 1 is a code word of length 2, we have 0, 0, 0, 1, and 1, 0, 1, 0, 0, 1, and there can be even longer code words such as this. Consider the English alphabet for the last example. You can see any English word as a code word then, and there is more. A is a code word of length 1, GCD is another of length 3, there is IBN, and there is this. Let me clean some space and continue. Our second notion is a code. A code C is a set of code words that have the same length. Let's move into the examples. For the symbols 0, 1, 2, up to 9, and for the length 13, all ISBN numbers in use form a code. Now recall that the number on the right was valid, and indeed it belongs to our book. But when Marta changed the 10th digit to 3, the number was rejected by the system, as it is not an ISBN number. So the number above is in this code, and the one below is not. For the second example, take the symbols to 0, 1 and length to be 5. Then all sequences of length 5 that contain 1 in exactly one position form a code. There are 5 code words in this code. And an error detection code consists of a message and redundancy. Redundancy. Is it like the check digit? This is a great observation, Alice. Exactly. The first 12 digits contain the information: EIN, group number, publisher, title. And the last one is the redundancy. And as you can guess, error detection codes aim to detect and possibly correct the errors after a noisy transmission. Noisy transmission. Is it like the stain I caused? That's true. And after the stain you caused, Marta is now trying to find the correct ISBN number. Indeed, this is a great point to investigate the limits of ISBN code in terms of error correction. In the first half of the story, Marta received a code with an error in the 10th position. She had 2 candidates for that digit, but for only one of them, the sum had 0 in the last digit. Indeed, 8 is the unique number among all possible values that makes it 0. I will explain this for those who know modular arithmetics. Given an ISBN number whose 10th digit is not readable, assume that we are trying to find out the value of this digit. We consider the following sum. Let's say y. All we know is, for a valid ISBN number, y is congruent to 0 modulo 10. But this means 3 times a10 is congruent to minus 1 times all of the other summands. We utilize the fact that 3 is multiplicatively invertible in modulo 10 with the inverse 7. Multiplying our equation by 7, we get the unique integer in between 0 and 9 that satisfies this equation. Hence, it is the value we are looking for. This calculation shows for all ISBN code words with an error at 10th position, we can recover the original code word. And there is nothing special about 10 here. The calculation, or an altered version of it, will be valid for different positions. So we can safely state that one error at a known position can be corrected. What about 2 errors, where we have the information of both positions? We already have this example where the computer couldn't decide the actual book that the code word belongs to. For a more general understanding, we use modular equalities again. Assume that we know all the digits were correctly transmitted except the 10th and the 12th. This gives us a modular relation. Namely, 3 times a10 plus 3 times a12 is congruent to y minus all other summands modulo 10. But this has more than one solutions for the pairs a10, a12. Actually, for any fixed a10 between 0 and 9, you get a different a12 that makes the equation hold. So Marta, the problem you are facing is beyond the scope of ISBN's correction ability. You can check the correct code word online though. I'll put the link. And yet, we have a last case to discuss. What happens when we receive a code word that we are sure there is one error, but we don't know the position? You may ask, why does one consider this type of a situation? Well, because in real life, we may not always have the information on the positions. So it is important to have a look at this briefly. Well, this is a code word, and by looking at the sum in modulo 10, you get 135. Hence, we successfully detect that there is an error. Now we will assume the position of the error. Let's say it is in the 10th position. So we want to recover a10. And to get a10, we solve this equation. At the end, we obtain a10 is equal to 8. As you may remember, this code word corresponds to algebraic function fields and codes. And assuming the 12th digit is transmitted incorrectly, we solve this other equation and we get a12 is equal to 3. To sum up, assuming the position of the error, we got different books. This means ISBN cannot even allow one error if the position is unknown. Now we ask ourselves how to allow more errors. We take the inspiration from real life once again. Yes, we have Alice. She's super hungry and craves pizza. One pizza margarita, please. And Bob, her friend working at the pizzeria, cannot hear her. Ah, correct. I almost forget to introduce him. This is Bob. He will also accompany us during our long journey. Say hi. Okay, where were we? Yes, Bob cannot hear her and she is really impatient. She tries again. Pizza margarita, pizza margarita, pizza margarita. Uh-huh, says Bob. She wants pizza margarita. Problem solved. Indeed, you can add redundancy to any code word. For example, for this one, you can repeat each digit 3 times and obtain the second one. And if the 0 in the 5th position is transmitted as 1 as a result of a mistake, the zeros in the 4th and 6th positions help us to correct it. And for a second example, we consider this ISBN code word. Repeating each digit 3 times, we get 999, 777, 888, 33. Oh wait, it's too long, isn't it? And this is precisely the problem about the repetition code. Repetition allows us to produce a code, but a bad one. Now we are ready to conclude our video. We covered the ISBN code and the repetition codes together with their properties. In this last part, we will discuss about how one should interpret these properties. We have some measures to compare how good the codes are. For example, a good code uses the minimal amount of redundancy while still being reliable. Repetition code does not perform well in terms of this, as it adds too much redundancy to the code word. And a good code allows a large number of errors while being able to detect the errors. The ISBN code cannot be considered good in terms of this, as it cannot even correct one error if the position is unknown. But don't worry, we will be making videos on better codes in the future, so stay tuned. Thank you so much for watching this and don't forget to share your comments and ideas with us. See you in our next video.